All right, so let's go back to parallel circuits. All right, parallel circuits. Well, parallel circuit. I guess I'm going to use red here, huh?
Sure does.
All right, is that series or parallel?
Series.
Why is it series? Only one path.
Parallel.
Now it's parallel. All right, parallel. So how do we solve for something like this? Well, E, I, and R. So we have 12 volts. E, I, and R. We'll say we have 6 ohms. And we'll say we have 4 ohms resistance. So can you solve that?
Yes.
Most of you can by now. I'll walk through this one with you. Those of you who are ahead of the class, you're already practically done. So we have, first thing we're going to do is we're going to add up the resistance. What's the formula? 6 plus 4?
No.
No. It is what? It's
1 over 6.
okay. So it's in your calculator. It's 6 1 over x plus 4 1 over x equals 1 over x. So I end up with 2.4 ohms. Now I'm going to check that. 2.4 is 2.4 less than the smallest resistor. All right, so that sounds like we're doing okay then. So now I can find the current, and we just use Ohm's law, which is E, I, and R over here. So I want to find I, so it's E divided by R, so 12 divided by 2.4 equals 5. So 5 amps. I got 5 amps here and 5 amps here?
No.
Nope.
No, not at all.
They got 12 volts.
I got 12 volts and 12 volts, though, because 12 volts and 12 volts right here. So the voltage stays the same, and now we're going to divide out the amperage. So
12 divided by 6.
well, it's 2 amps. That must be 3, because 6 times 2 is 12, and 4 times 3 is 12. And so what's happening is the amps are coming, because amps is flow, right? So unlike voltage drops, so I have a total of 5 amps right here, and two of them are going to go down this way, 2 amps, and 3 of them are going to continue this way and go down that way. So 2 here and 3 over there, and that's the way it's going to work. And the 3 are going to come back this way, and they're going to catch up with the 2 over here. And so by the time we get to here, I've now got 5 amps again. So if I put an ammeter right here, what's it going to say?
5 amps.
5 amps. So I put an ammeter right here, what's it going to say?
5 amps.
5 amps. If I put an ammeter right here, it's going to say 3. And if I
3.
put one here, it's going to say 2.
Could you please go over finding the total resistance?
You bet. In this particular one, in my calculator, I put 6, and then I hit the 1 over X key. Then I hit plus, and I hit 4. I hit the 1 over X key. And then I hit equals. And I'm going to do it real quick. 6, 1 over X plus 4, 1 over X equals, and what it's going to equal is 0.41666, on and on and on. But that's not my answer. I'm going to hit the 1 over X key again.
Where is this 1 over X key?
Right above the EE key.
No, exactly.
Oh,
This is
you
a-
don't have the X minus 1, sorry. X minus 1 for you.
Okay, so 6 minus 1.
So this is the X minus 1 key. All right? So same operation. You don't have that one. You have the X over 1 over X. You got it?
Yeah.
All right. And so what we're doing is it's resistance total equals 1 over 6 plus 1 over 4, which equals R total equals, let's see, 6, 1 over X is basically 0.166 plus 0.25, and that still has the 1 over. Sometimes you'll see the 1 over the R total, but that's how you do it, all right? So you just have to remember to do that.
Could you go back up to your circle?
Right there?
All right, cool. Thank
Do
you.
you get it?
Yep. Good.
All right.
Hand up.
What would be an example of a parallel circuit like in an airplane?
Okay. Let me do 1 or 2 more here, and then I'm gonna schematically. Well, I should say schematic. It looks a lot like this. I mean, it's a parallel, but we're gonna do one that's more realistic. So, and a little more difficult. So here's my battery. Three. All right, so I'll just do the 3 ohms, 6 ohms, not G ohms, 6 ohms, and we'll make this 12 ohms, and I'll make this 12 volts.
$12 ohms and 12 volts.
Mm-hmm. Resume. All right, let's solve this thing. First step is what?
13.
Somebody want to let Nick in? He locked himself out. All right, first thing is to do what?
Total
Our
resistance.
teams.
Okay, we can do 2 things here. What are the 2 things? Total resistance and what else? Voltage. So we know it's 12 volts, 12 volts, and 12 volts. Not a hard thing. All right, you want to do total resistance? Let's do total resistance. So what is total resistance? 3, 1 over X plus 6, 1 over X plus 12, 1 over X equals. That's 0.5833, but that's not the right answer. I'm going to hit the 1 over X key, and I'm going to come up with 1.714 works. 714 is fine. Ohms. Okay. Current.
12 divided by 1.714.
12 divided by 1.714. 1.7. 12 divided by 1.714 equals, what do you guys have?
7.
What?
7 amps.
Well, I must have messed up. 12 divided by 1.714. There we go. 7. Want to call it 7 amps? Okay. So 7 amps, 7 amps, 7 amps?
No.
Same? No. Okay. How many amps are here?
4.
4 amps. Okay, let's check that. 3 times 4 is that. Oh, we check this. Does that sound right? Is that smaller than the smallest? All right, looks pretty good. This must be 2 amps, and we're left with
1 amp.
1 amp. All right, that was not hard at all, was it?
Well, so you just divvied out the 7 amps between the 3 resistors?
Well, yes, I did, but I did it mathematically. So I didn't know the 4 amps, so I just used EIR, and I wanted to know I, so I did 12 divided by 3 equals 4.
Right.
12 divided by 6 is 2, and 12 divided by 12 is 1. Then I can look at it backwards. 1 plus 2 plus 4 is 7. Just like I do on a series circuit when I'm taking a test or checking a paper, I add up all the voltages and it better come near the total. Doesn't have to be exact, but it better be close to the total. And same thing here. So I'm going to add up all the amperages, and it should be close. All right, one more.
Yes, please.
I did not give myself enough room.
Stick with 12 volts, so I don't gotta erase that.
Okay. 12 volts. And this time we're going to do 0.5 amps, 3 amps, and 2.5 amps. And you can figure the rest out.
It says 12, right?
Huh?
12 volts.
Yes.
Well,
All right, ready to solve? Okay, there's two things that we can do if you're lost. One thing we can do is what? Voltage. We can do voltage, or we can do
total current.
total current. So we can complete I or complete the volts. So let's do volts because it's easy. 12, 12, and 12. All right. Now we can complete the current. What's current?
6 amps.
6 because it's 2.5 plus 5 is 0.5 is 3 plus another 3 is 6. So we have 6 amps. Therefore, if E equals I times R, and I want to know what R is, it's E 12 divided by 6 equals 2 ohms. Well, how in the heck am I going to figure out how to put those in there?
Divide by 12.
Well, just look at it right here. So R equals E 12 divided by 5 is what?
24. That's where I got stuck.
24 ohms. 13 or 12 divided by 3 is 4 ohms. And
4.8.
4.8 ohms. And just add them up, and that doesn't equal. Huh.
No.
You got
Oh,
it.
yeah, you don't add them up, right. So what's the rule?
You got it.
This should be smaller than the
Smallest resistance.
small. Is it?
No.
Yes.
That's a good indication. Oh, Tim, you remembered. All right. Let's try something a little different. We'll do that tomorrow. All right.
No handout?
Well, I got a handout. We got to get through this one first. Okay, so I have a certain schematic here. It has, with a 14 volt power supply, it has a 7/8 horsepower motor that is 65% efficient. I have a 100 watt landing light and a 2 ohm something. 2 ohm thing. I don't know what. Cigar lighter. You guys ever notice? Yeah, I haven't. Aircraft do not have cigarette lighters. They have cigar lighters. It's very interesting. If you read the parts book. So battery.
You gotta be supposed to say.
All right. So that's something you can do.
Well, what are we actually looking for?
14.
Create that circuit and solve for it. Now I could just let you add it, or do you want me to walk you through it? Okay. So you're going to get something like this on your test.
On Friday.
On Friday. Oh yeah. All right.
Does that say thing?
Yeah, because I couldn't think of. It's whatever. It's a toaster. I don't. It's a coffee pot or something. I don't know. Okay. So if you get it written out like that, create it.
Is this one?
Now, did I say it's series or did I say it's parallel or none of the above? Well, it's if it's in an aircraft, it's got to be in parallel because if it were in series and I had a light right there, what happens to the motor if the light goes out? Oh, the motor quits. Well, that's not very good then, is it? So I have a motor. I have a landing light. And I got my thing. So I got to solve for the circuit. EIR. And when you see stuff on the test, even the FA test, they give you something like this. They may say something like, what is the current through the motor, or the current through the resistor? You know, I solve the whole thing. I just solve it all. I try and worry about that one component. I look at this, and I'm just going to solve the whole thing. All right. So what do we know here? We've got 14 volts.
Everywhere.
I've got 2 ohms. I'm just going to fill out what this tells me. Well, 100 watt. Well, shoot. Well, that's down here with P. So I got 100 watt. And all right, we got to deal with this motor. Do I have any information here?
You have the power.
I have the power. Do I have the power? All right. So 7/8 horsepower. Well, let me do this. 1 horsepower is equal to what?
760.
1 horsepower equals 746 what? Watts. I'm going to scroll down. We're just going to deal with the 7/8 horsepower motor. We'll go back up. So 7/8 horsepower that is 65% efficient. And we know that 1 horsepower equals 746 watts. All right. So we got to think this through here now. What's the first thing I can figure out?
100%.
What's that?
7/8 horsepower.
Okay, 7/8 horsepower. Then how many watts is that? I want to convert this to watts.
7/8 times 7.
Right? Well, 746 watts is how many horsepower? 1. Then 7/8. Do I want to leave it in 7/8?
No.
Decimal. What's my decimal?
0.875.
Okay. Is how many horsepower? So 1x equals,
652.75.
I'll do it long way. So 1x equals 746 times 0.875 times 0.875. So x equals 652.75 what? Watts. Okay, so I've got this. I've decided that this motor that was built is 642 watts. Now think it through. If I said, well, I have a 1 horsepower motor, then it's 746, but it's not. It's 7/8, it's a little less. So it's 642 watts. So it's not quite a full 7/8 of a horsepower. So now I convert it into watts, something that's in electricity, something I can use. So can I go back up and plug this in? Why not? Okay, I got this efficiency problem. What is that all about? Well, in a perfect world, if I said that this was a motor that put out 1 horsepower that was 100% efficient, how much power do I suck out of the wall?
746.
Right. So I suck out 746 watts into the motor that puts out 746 watts or 1 horsepower. Follow me? But it's not. 65% efficient. So if it's 65% efficient, does it suck more power than it puts out?
Yes.
Or does it put out more than it sucks?
Sucks when it comes out.
These really nice words I'm using here. But it means that it takes more power and it loses it in somewhere in the motor. In friction, bearing loss, EMF losses, all this. So we need to figure this out. So how are we going to do that?
625.75 over 65.
All right. So what's that? So 652.75 watts. And what was that again?
Over 65% efficiency.
Why am I going to do that over 65?
Because that's exactly what it is.
Because it's what it is. And what do I want to know?
X over 100.
And why is that?
Because you want to know how many watts if it was over 100% efficiency.
That's exactly it. Then what is 100%? What is it taking out? So 652.75 times 1 is 652.75. And x 0.65x. So I just divide both sides by 0.65. And I get 1004.2 watts. What does that mean? The 1004.2. Where now what am I supposed to do with that? Yeah.
I just want to clarify to make sure but shouldn't the 652.75 be over 100% because that's what that 7/8 horsepower motor puts out at 100%?
No.
We're trying to find 65%.
Okay, so we'll back up just a little bit. I want to think of a nice way to say it.
Might have flip-flopped in my head.
Just a little bit. The way that I like to think about it is remember that the output, let me go back to this. The output is what? How much? 652.75 watts. Okay, so what is the input? Is the input more or less?
More.
It's got to be more. So you could do it both ways. You could try dividing that. You're going to get a number that's much smaller, but really we're just multiply it. You have to divide it. So I actually do something like this. At least in my brain, I don't maybe put it on the paper, but I think about my output is this, so my input got to be more. I put a little more right there, equals, and so 652.75 divided by 65% is 1004.2 watts. This is how much wattage it takes to drive a 7/8 motor that is 65% efficient. So if we look at it one more time and go back, the first problem was it's a 7/8 motor, not a 1 motor. So you got to figure out what's 7/8 of 1. Okay, then once you got it, you say it's 65% efficient, which means that it's rated output. So it's rated at its output, but hidden in that is how much power it's using. And so that's what we really want to know is how much power it's using. So how much power is it using?
1004.2 watts.
1004.2 watts. All right, that's enough here. I think that we could solve it once you've done that. That wasn't so bad. Okay, so I'm going to say it's 14 volts, 14 volts, 14 volts. Can I solve for my resistance?
No.
What can I solve now? I'm kind of stuck.
You can
Current here, current here, and current here. So how am I going to get that current there? Well, remember it's pi. I like pi. P equals I times E. But I'm trying to find P, and I have P. So we just move things around a little bit. 1004.2 equals I times 14. And now what can I do to both sides?
Divide by 14.
Divide both sides by 14. That's going to solve for me. So what do you get? 7.1? 7.3 amps. All right, do the same thing over here. So it's really just 100 divided by 14. $7.14. And what do we get over here?
14 divided by 2.
14 divided by 2? 7 amps. Now I've got my amps. So 7 plus 7.14 plus 71.73 equals 85.87. And now resistance is slam dunk. It's just Ohm's law. E equals E divided by I equals R. What?
Ohms on the right, was it?
It was a given.
Okay.
I usually change color for givens. That was a given. That was kind of a given. 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 Right, so R is what? 14 divided by 85.87. So we got 0.16. You guys are very quiet. .195. What do we have here?
14 divided by 85.
Oops, it's 0.16. Sorry.
0.163.
I have 0.16. 0.195. 1.96. And 2. And is this
195.
smaller than the smallest?
Yes.
Yes, it is.
Oh, that's a doozy.
That was not hard.
That's pretty easy.
Just little bites, little bites. Yeah.
How do you know that it's like a motor that is like the 65% efficient? Because I kind of got confused with that one. How do you know that it was taking up more than 7/8 horsepower rather than it's giving out 7/8? Wait, no, that's the same thing. Like,
Let's do this. Let's.
The 7/8 regardless.
What if I have a 1 horsepower that is 75% efficient? Okay, 1 horsepower is how many watts? 746 watts. And it's 75% efficient. How much power does it take to run it?
X.
75%.
So it's 746 is 100%. Then what is 75%? I'm going to change it to decimals. So it's 1x equals 746 times 0.75. And so x equals, what is it, 1094?
194.
Huh?
199.
Well, I can't understand what you guys are saying.
994.
Thank you. 994 watts. Now, 994 watts. What?
59.5.
Oh, man, I do myself now. 746.
559.5.
Oh, we did. What the heck did I do wrong here?
You put the 100 over underneath the 740.
Up.
Yeah, how do you know it's not like 75% of 1 horsepower, or if it's like
What?
it's running at 75%?
I was getting-
and it
It says the
takes-
output.
That's what I
It
was
isn't
wondering.
like it's,
Huh?
the output is 1 horsepower. That's all. That's the
The output. The data plate is what the output is. How much does it take in?
So is that always like the output?
Yes.
Yes, data plates are always output. As far as I know, never what it's drawing. So we have to figure out what it's drawing.
Gotcha.
So it's going to be 75% more.
Just to clarify, is that like
Yeah.
doing a spur gear, like you had to flip the ratio? Because I'm thinking about we did like the efficiency of a motor, like if it puts out this much horsepower at 100%, then what's it putting out at 75%? That's where I was getting confused.
Oh.
I had about doing that.
Yeah, if I understood. Yeah, no,
That's what I was.
it's what does it take in, what does it put out. So. Um,
94666.
that's so.
Are you gonna write this one out? Because I got the answer that everybody else got, but the way you explained it totally confused me.
Yeah, what answer did you get?
I got
994.
559.
The 559. Okay, so we got 559. Is that right?
No.
How do we know it's wrong?
Because
It's less than.
It's less than. This is less. So what that's saying is if I take in 559, I put out 746. Is that right? Oh, that's way wrong. That's way wrong. So
9, 4.
so it's. I was trying to think of a formula the way I can write it, but it's 746 is it's what
75.
it's what how can I do this? It's 75%. That is the 75%. And so I need to figure out what is 100%. What
But I thought 1 horsepower was.
So,
no.
so what you're saying is we're putting out 75% of 1 horsepower, but we're trying to figure out how much we're using in order to get that 75%.
This is what I was trying to do. Yes. So this is output, and then percent efficiency equals X input. So I'm just going to erase this and pretty much just write exactly what I just wrote as I say it. So I have my output is how much? What did I say the output is? The data plate on the motor says output is what? Said 746. And the data plate tells me, the plate on the, how efficient is it?
75%.
Or the book or something, it says it's 75. I'm just put 0.75. And I want to know
What's 100%?
what's my input. And my input is always 100%. So how much is going in? What am I taking in? So that's 1. And this is my what I want to know. So input. I should just leave that at 100%. That looks better. 100% input. All right. So 746 equals 0.75x. Divide by 0.75. And now what do you get? 994.6.
6.
We'll leave it at that. 67. All right. So if I draw 994 watts of power and I only put out 746 watts, does that sound like a motor that's not entirely efficient? And that's what we said.
Sounds about 75%.
Sounds about 75%. So so if you wanted to check this, I got all done. I'm like, well, let's check that. 994.67. I have that in my calculator. Times button. 7.5 second percent, which is also the 2 key on, I think, on the calculators. So 994.67 times 7.5 second function percent. It'll convert it to a decimal right there in front of you. Equals.
Where'd you guys get that 559 from earlier, or whatever that?
559.
That was set
Yeah.
up out of the four
Oh, that's if you did it backwards.
Oh, okay.
If you set this ratio up backwards and you get 559, stop and look at it and go, wait a minute. It takes 559 from the wall and puts out 500. Hey, I'll take that every day. Let's hook that up to a generator and create, I've got perpetual energy going on. That's a good thing. I want that. Doesn't work that way. So you know it's wrong. So, and I could see on some of the other tests, you guys kind of missed that. Just stop and take a step back and look at it and go, does what I'm saying sound logical? All right.
Hey Kevin.
Yes.
So in theory, you could just take that 746 and divide it by 75% and get the same number.
Sure, which is probably the way I would just do it, but I was trying to show you the ratio to do it, because once you could, because if you forget that, then you could. Oh, I have notes right here. What you get, what you. Let me write. Obviously, I thought about this once before. I put. This goes back to the original, so 652 over x. Remember that one from before? Equals what you get. This is a little bit different. Over, nah, wait a minute. What you paid to get. Paid to get. So just a different way of setting it up, and that ended up being 65%. And this ended up being 100%. So just another way of setting it up. I like that one. So you remember where we got the 652 from? That was from the original question. We got 652 watts. So another way of saying that is, we could see horsepower. We could say horsepower output. Wattage output. That's what we want.
Yes.
Making this up on the fly here. Watt output. And this could be watt input equals what you get. That was 65% versus what you paid to get, which is 100%.
But if you know the ratio formula that you gave us, you can kind of make this up on the fly.
Yeah. Okay. I'll throw this at you.
Literally?
What?
Figuratively or literally?